So just an overview of what I'm going to go through here, just starting with the current status. And I'm going to cover how people do risk assessments, because I think it's really important for us to understand the framework for discussing these issues in a little bit more constructive and productive manner. Movement and persistence of pesticides and other materials in the farm, field environment, and the aquatic environment. The things that affect toxicity, the toxicity modifiers. And finally, best management practices and how important they are. So getting into the current status, there's no doubt that fish kills in PEI are associated with agriculture. Soil and water management practices have reduced the number and severity of these fish kills, so progress has been made, but more is required. Pesticides of concern have tended to move with the water and soil in runoff. So as storm events get more severe, we have to be ready for that and try to take action to prevent it from being a problem. But today, mitigation or remedial action has been focused on managing soil and water and tracking progress with the detailed engineering assessments that have been recommended. The bottom line here is that keeping agricultural soil and water in the field is necessary for sustainable farming. All the talks you've heard this morning so far and some yesterday have pointed in that direction. It's also going to help with protection of aquatic species and fish. So what are the next steps in moving the science in this area forward? The next step is to get a better understanding of the causes. One of the key problems that I've seen in Prince Edward Island over the years is every time there's a major event, there's uncertainty. There's uncertainty as to what really happened, how did it happen, and why did it happen. So we need better investigations. We need better data about how things fit together. We need some serious progress in this area. What are we trying to achieve? I'll have more to say about that later. The process of risk assessment is what I want to focus on. This isn't the first major public issue that has affected agriculture. And areas like the Tennessee Valley Authority problem with their strip mining of coal led to the development of a kind of framework for bringing people together in a potentially adversarial situation like this. So what is risk assessment? The core of it is around how you put the toxic effects of, say, pesticides or ammonia or excess manure running off the field. How do you put that together with what happens as a result of that release? So the first part of risk assessment is to measure the toxic effect of a substance, to know how toxic it is. This is done by doing acute tox tests, single exposure type tests. It's done using chronic lifetime exposure tests. It's done using specialized tests for cancer, for all kinds of disease endpoints or toxic endpoints. And this is where a lot of people stop, especially the media and the environmental protesters. Once it's toxic, it's deadly, we're all going to die. Well, I think it's really important to realize that that's not true. We all know that every vehicle produces carbon monoxide, plus polynuclear aromatic hydrocarbons and toxins and carbon black, which is a known carcinogen. And yet, the Ministry of Environment doesn't arrest you when you start your vehicle, nor do you die. Because there's another factor there that's involved. Exposure. How exposure plays out over time. Is it an immediate dose, or is it spread out over time? Is it a repeated dose? So risk assessment takes toxicity together with exposure and comes up with a measure of risk. So what I'm advocating with this is, for example, you have that PEI list of which chemicals are the most toxic. That's based on this upper left circle, or ellipse, alone, and it doesn't take into account the exposure. So risk is measured by comparing exposure to the toxicity level, and is there enough exposure to actually cause harm? So risk assessment also needs to consider the route of exposure and compare the right toxicity to the right route of exposure. So an oral exposure is going to be different from a dermal exposure. It's going to be different for fish gills versus the skin of the fish versus the food of the fish. The time needs to be considered, as I said. Is it short term? Is it long term? Is it pulses? This is another big thing that's been neglected in the assessment of fish gills, because a lot of people are unaware that most of the toxicity reported is for a 96-hour sustained exposure in a closed system. That's not what's happening as far as we can tell in the field. We might get a 1 to 2 hour exposure. What does that do? We need to know. The other thing is that the exposures in the lab are done in pure water. You know, it's got the minerals in it, but it doesn't have any organic matter. That really affects how toxic a material is. So I'll talk about toxicity modifiers later. Underlying all of this is the question, what are we trying to achieve? So when you have a group of people, especially in an adversarial situation, you need to get together and agree on what we're trying to achieve. What are we really trying to protect? And set those goals, and then go out and measure against those goals, because otherwise you're just testing everything in every different direction aimlessly, and without a goal you're not going to get where you want to go. So setting protection goals sounds really simple, right? But when you're protecting fish, are we trying to protect every individual fish? You know, stop commercial fishing, stop recreational fishing if you're trying to go in that direction. Or are we trying to protect a population? Do we want the same numbers of fish to be available in every stream and the same species to be available in every stream? Do we want to protect every stream, or just the streams that are outside the city? And what about protecting those streams that used to be in the city? Third possibility is, do we want to protect at the ecosystem level? Do we want to not just protect the fish, but the things they feed on? Maybe we need to consider some of these things before we do our risk assessment and come up with agreed upon goals. So the other aspect of this, I mentioned a little bit, do we want to protect in the city or in the country? We also need in the country to figure out, do we want to protect and measure water concentrations in the field? There's no fish there. What about edge of field? It's reproducible, and it is worst case. Or what about just measuring in the stream where the fish are, to be sure we're actually measuring something that is a risk to the fish? So now we move to the pattern of exposure. That's sort of, up to now, has been the toxicity framework of what we're talking about. Now the exposure framework. the infield water concentrations can be 1,000 times higher in the rills and streams. And work done by people like Bill Ernst has shown this, because they took samples right in the field. The edge of field, which I mentioned, has lower concentration. In the stream, the concentration is quite low. It's averaged out because of all the mixing of water from different fields and from already within the stream. So that points to another thing that we need to include in our consideration. We need to include the base flow of the river, the existing flow. So it might be a better situation if you have 2 storms in a row than if you have a single storm just after somebody has applied some material. So the other thing we know about our situation here in Prince Edward Island is that these storm peaks have flow intervals that last only 1 to 2 hours. So the flow of water is suddenly changing from clean, relatively clean water to muddy, sedimented water like you've seen in some of the pictures. It's got things in it, it's got ammonia in it, it's got salt in it, it's got all kinds of things in it. It's got bacteria that don't normally get into the stream water from the field. And it's got a change in temperature and salinity. So all these factors need to be measured. And they all interact. But the important thing from the duration of time is this helps narrow our focus on what we need to do. It helps us to think only of those short-term exposures called acute exposures that correspond to the kind of exposure that the fish would have in the field. The other thing that we need to know is, regardless of what kind of protection you put in place, you're not going to get perfection. A big storm event will overwhelm a barrier that you can put in place. And so this tells us that we need to set some kind of a goal, like we want to protect against the 100-year storm, or we want to protect against the 95th percentile of storms. Whatever that goal is, it needs to be agreed to by the people who are involved, and not by scientists or engineers necessarily. They have their role to play, but consensus is what's important. So that at the end of the day, when you meet those goals that were set, you're free and clear. You're not going to get hammered again and again for an unachievable, unstated goal. So the amount of chemical in the water changes with time during a storm event. There may be more at the beginning, there may be more later on. That's important too, to know that profile. So things like persistence, movement, physical form, whether it's dissolved, you've all heard of these things. The other thing that I want to focus a little bit more on today is the area of bioaccessibility, bioavailability, and whether or not materials are extractable. This is important because you can get confused. For example, if you take water samples, you can measure glyphosate in those water samples. But the way the physical form of that glyphosate being tied up, it's easy to extract it for measurement, but it is not biologically active, and you know that if you take that water and spray it on plants, you will not harm those plants. It will be completely herbicidally deactivated almost immediately on contact. So you can't just say, well, because it's there, it caused harm. So, just moving ahead here. The degradation pattern with time after application is critical because this affects that bioavailability pattern. So here's a graph of from a computer model to fit the data that is the concentration of pesticide in soil in the root zone versus time. So on the vertical scale, you have percent of what was originally there. On the horizontal scale, you have days. And you see there's two lines there. The lower line is the dashed line, and that's the line that would be predicted if you had a single process going on. What you see is the two lines are pretty much together initially, but then the real measured line diverges upward. It takes longer and for the material to degrade, the degradation starts to slow down. What's happening there? Actually, what's happening is that pattern indicates that there's more than one process going on. There is one process where, one compartment where the material is immediately available to microorganisms to degrade. The other compartment is inactive. When you put this together and realize that the extraction solvent for analysis is going to sweep out everything. So the measured values have to be the sum of those two compartments. You put this into a model and you see that at early times, you can see this arrow F3. At the early times, everything's available. It hasn't had time to really sort itself out into different compartments. And the process is dominated by F3. Later on, this available compartment gets depleted, and the non-bioavailable compartment starts to drive the process. And everything is driven by what is the rate of release from that non-available compartment. So as soon as something is released, it's degraded. So, and the microorganisms are doing this because they want the nutrient out of whatever it is. For example, a lot of pesticides have nitrogen in it. So the microorganisms are going after the nitrogen. So here it is together in the full output of the model. And you can see that that two-compartment model explains the data extremely well. The correlation is almost perfect. So this helps us to understand why we need to focus on that early part, the early time frame immediately after application of a compound on the field. We're not worried about things that were applied last fall and there's a little bit of carryover. We're not worried about things that were applied last month. So those are two big key drivers for where we can focus our assessment of the risk of these pesticides or other materials in the runoff water. So now, toxicity modifiers. Things have different toxicity in different environments. For example, delta methrin and a lot of the pyrethroids measure very high toxicity to fish in the lab. Almost no toxicity to fish in the field. Completely non-toxic. Again, it's because they're tied up with the colloidal material, the organic matter, in the water. And you can't even see that material in the water. There isn't a lot of it there, and it's so mixed in with the water that you can't see it. But if you measure it, you can see that it's there. Other things that affect the toxicity is pH, hardness, salinity, organic matter, temperature of the water. The higher the temperature for a lot of compounds, the more toxic substances may be there. pH has a very complicated effect on toxicity because it can change the availability of the material and the uptake. Organic matter has a big effect on toxicity. So, and these things don't just affect the toxicity side of that equation, they affect the exposure side through changing the bioavailability and the uptake. So another thing that is important to realize, just to, if you think that was complicated enough already, sudden changes in these parameters can affect organisms. For example, fish can be quite comfortable at 16 degrees or 18 degrees, but they cannot take a sudden change between 16 and 18 degrees. So a few other things on the slide there, ammonia, fertilizer. I think it's really important to try to look at this from a more holistic point of view, look at the details carefully, and see how they all fit together. And it does take the extra effort, to, not just to understand that, but to communicate it. The bottom line is that all of this is going on in the soil and water that ran off the field. So, looking at the big blue sky picture here, you can see that keeping that soil and water in the field takes a lot of that uncertainty and complexity off the table. And it has the added benefit of contributing to sustainable agriculture. So that leads us to best management practices. What do we do to achieve that goal? And here are some of the things that you've heard about. The main thing is buffer zones. And I'll try to go through these quickly in terms of what's the cost and what's the benefit. With the buffer zone, you lose, well, at one time you lost 10 meters, now 15 meters. You're losing agricultural land that you really don't want to lose. But the benefit is you really, really cut the risk of loss of soil and water from the field and harm to the aquatic system. So there's a big benefit from this. Grass waterways, again, one of the biggest and most well-proven ways of preventing erosion in the field. With straight potatoes, you get about 89% of your runoff after the first inch of rain will be lost as runoff. You know, you can cut that to 65 or 70% down the grass waterway. The other thing that you can do, and I don't know how many of you are at all interested in using these dammer diapers? Anybody? Not a wave of enthusiasm. So, but it does help you to farm longer slopes. And if you don't have the slope body, you still have to try to keep that water in the field. They have been proven to be effective on farm. It's not just a theoretical thing. The other thing is crop rotation. Crop rotation is hard because it takes, if you go from a 2 to a 3 year rotation, you know, you need that much more land. And that land is in short supply in some spots, especially woodland for growing potatoes. So that's a more costly endeavor, but it's still necessary because you've got to think not just about saving the fish. You've got to think about saving the farm. You've seen the numbers. You've seen the decline in organic matter. You've seen the decline in soil tilt. Over the years, your yields are going to start going down. And when your yields go down and your costs are going up, there's going to be a sad day when they meet. So you have to try to do your best to put that day off. So the other ones here, it's critical to manage fields individually. You may have some fields where there's just too much runoff to be worth keeping in potatoes. So your goal there should be different. The goal would be how to get that field producing cash in a way other than potatoes. And there are ways to do that. But if you focus your attention on it, you know, what gets measured improves. The other thing that can help things is knowing what and when to spray and how to spray it. So one of the things I'm recommending, although I haven't heard a lot of people doing it here in the island, is banded spraying. And the reason I'm recommending that is if you spray in a band, especially with a fungicide, you can cut your rate per hectare. You know, if your rows are a third of your land area at an early stage, you can spray at a third of the rate. You got the dollar savings. You still pay for the diesel and the time, but you've got the dollar savings of that rate cut, and that can be substantial. So there is a direct benefit to banded spraying, and it may be worth the investment in trying to put that in place on the farm. And final thing about this is you can't do it all at once. You've got to see what works, just like when you've got a new variety. Does it work on your farm? Does it work in which field on your farm? You've got to think about how to continuously improve towards cutting the risk. After there's no more fish kills, you still have to cut the risk of harm to your soil. So conclusions, pesticides show rapid initial degradation followed by slow degradation. So we want to focus on what's been recently applied. For fish and PEI, the focus is on pesticides, on soil carried and runoff shortly after application. Keeping agricultural soil in the field is necessary for sustainable farming and protection of aquatic species like fish and also other aquatic species, the things that fish feed on and depend on. Much has been achieved, more is needed, and the way to get there is to actually track your progress. If you put in berms, how well did that reduce the peak flow in the stream next? How well did that improve your organic matter retention in the field? Did it at all? Do other things make improvements, and can you measure those improvements? But there's no point in putting a practice into place that doesn't actually add value for a reasonable cost. And the other thing is, the final line is, you know, the combination of compliance with these good practices, stewardship and care for the land that you'll be passing on to the people coming in the future, and good science. And there hasn't been enough of that combination. I think there's been, you know, I keep saying there's two kinds of people when they're faced with a problem. One kind of people make up a story to sound important, and the other says, let's get together, figure out what happened, and solve it. And I'm in the latter group, and I hope to be able to make a contribution. So thank you very much. With that, I'll open it for questions.
In the past, there's been used a lot of smaller ponds and dams and small things. That's been discouraged. Would you comment on that?
Water retention is a pretty important piece of the picture. And when you think about it in a broader way, let's say the same kind of issues happen in the city. Storm runoff has to be managed, and it's done with storm management ponds. That hasn't been tried here. When they're building roads, they use straw bale dams. That hasn't been tried in an agricultural setting. So you're right on, you know, that kind of water management needs to be in the picture, and that's why we need the expertise of the ag engineers to tell us how and why and where to use them. So, absolutely perfect.
Have you ever tried to get a permit to do anything in the stream around here?
Yeah, it will require a change in the outlook on how water is managed. But that is where this risk assessment process is what I'm recommending, because in order to make major policy changes like that, you have to build consensus. You can't just do it on an individual farm level. You have to speak out. You have to get the round tables. You have to be there with the people who don't agree with you. Be on the ground and ask the good questions. You know, one of the questions that I would like to see every time someone comes on the radio and starts telling you how wrong your farming practices are, I would like to see somebody say, well, what professional credentials do you have and what evidence do you have to back up what you're saying? Those questions are never asked because the story would go away quickly if they were sometimes. You know, but frankly, we do need to. Yeah?
Are you allowed to transport the soil from the buffer strip back out to road areas?
Unfortunately, no, because if you read the Act, you need a special permit. Well, you could do it if you got a permit to work in the buffer strip. And then again, you would want to work with your ag engineers. And keep in mind what was said, was it yesterday or today? Bringing that soil back up, you still lose a lot of the value of it, but it's still worth doing. Keeping it in place is the best option, but I think there's merit in
I'm
that.
saying over time, like 30 years from now or whatever, you know, you're going to have a nice bit of soil there on the inside of the buffer strip.
Oh yeah, and I agree. I think that's going to be part of the picture.
What about weed control in the buffer strip? What are you allowed to do? Just mechanical?
I think you could, you know, if you really need to maintain that vegetation in the buffer strip, I think you could. Is there anybody here from Ag that can answer that? I got to check the regulation. I think you are allowed to do a number of different things. You're allowed to play all of them.
Less than inventory strategy.
Yeah, well, I got my John Deere mower over there.
It's, you can, every 5 years, you can actually plow and reseed your buffer zone what you want. They get a permit for it. I'll let government know, but for the livestock folks that say they'll be inundated with weeds, that provision is in the legislation, the regulation, allow them to do that.
The other question I'd like to see answered, and I don't know the answer, is how much of a refuge is that sod and grass and weeds in the buffer for wireworms? You know, do they just move back in? Don't know if anybody's here to answer that.
I'm not trying to answer. No, I'm just going back to something Sterling said. I live in the city of Charlottetown. I live on a stream that used to have 8 ponds on it. I have the only pond left on it. There were 6 above me and was one below me. As a boy, I used to be able to get 1-2 pound trout with no problem up pretty well up to the second last pond, which would be up in the Winslow. Today, the stream it flows quick with runoff, and then it flows to a level where all you get there is 3 or 4 inch fish. And the biggest runoff problem on that pond is not from agricultural land above me, it's from the Royalty Junction Road, which has been deep ditched down into the shale and rock where there's no vegetation, grows on the sides of these ditches. So whenever there's a heavy event, you've got exposed dirt, whatever,
Exactly.
that creates a problem. And my pond silts up every 2 to 3 years because of that. And and I've seen it all across the island. We had an island full of beautiful ponds and dams, and I really think that the province needs to look at a program that will allow us to rehabilitate some of these water retention things and the aquatic life that they attract, as opposed to focusing just on a little stream, which if the runoff is is gone through it, and then it's just and in the summer it dries up.
That's right. See, well, that's one of the reasons that I started thinking about this risk assessment process, because it brings in the urban issue as well as the rural issue. The same thing was recently published on a big study out of Seattle. They found that the fish kill was correlated to the amount of pavement in the area being studied. And the reason for that is, of course, the water surges are hurting the fish, the tire dust is hurting the fish, and when you get an urban setting, there's no concern, whatever, if somebody builds a big new shopping center right through a stream, takes that stream right out. Well, let's have an equal playing field. If the fish are such a concern, let's have some of the urban people make a change in their lifestyle. We're not asking them to put in a $30,000 burn, but we are asking them to be aware that they're part of the problem.
Just get back to our mission with the buffer zones. I don't know the answer, but Dr. Baldwin was here a few weeks back, and definitely buffer zones is one thing, are perfect habitat for water populations that will migrate into the fields.
So you should be able to spray those or do something, you know, but you can't. They'll take them out. Oh, we had it. Yeah. Yeah, I forgot about that. Yeah. You can't spray in the buffer zone, but is there a product that you can use that you could spray? I don't think there's. Yeah. That's another problem. Yeah.
You mentioned there was a report of the very to fish in the lab.
Yeah.
And you read the same thing about fungicides.
Some fungicides, but fungicides are highly variable depending on the mode of action.
Is there a clear list then of the ones that had a more bioavailability to be more concentrated?
Yeah.
And this
PMRA does that in their risk assessment, and you know they use a different rating system. They compare. It still doesn't go all the way, I'll tell you why, but they compare estimated exposure to toxicity and come up with what's called a risk quotient. These aren't widely published, but they are in the PMRA assessments. They're not in the final published decision, but they are in some of the preliminary documents that PMRA publishes. So you get the risk quotient and compare those, and you can see that there will be a ranking of compounds. And it's odd that it's kind of independent of whether it's a herbicide, fungicide, or insecticide. It's whether it's toxic to fish or not that counts. So you can come up with a list like that. And so, you know, you can see products like endosulfan pretty high on that risk quotient list. So they've been eliminated.
The MSDS sheet with the LC50,
Yeah.
which will give you tell you the toxicity of some species of fish.
That's half of it. That's the upper left-hand corner.
Again.
Yeah, but then on the right-hand side, you have the exposure, which is called the EEC, the expected environmental concentration. You divide those two numbers and you come up with the risk quotient. And you get, you know, you might say, well, if that product is used at a really low rate, that doesn't count. What counts is how much does it take to harm the fish and how much the fish is likely to be exposed to. So a highly toxic compound with a high probability of exposure will have a high risk. It doesn't matter if it's used in a very low rate. Yeah.
Just in reference to the buffer zones, if there is something to the brown mustard thing, allowing the field side 6 meters of the buffer zone to be planted in brown mustard, I think.
Yeah.
I mean, certainly I've
You know, there's-
seen that tested.
There's some thinking that, you know, we really should look into something like that. Does everybody understand this idea of what the risk is versus what the toxicity is? Because I think that's a really important thing that you can use, make sure your family knows about it, that you're not killing the fish, you know.